Hello and welcome to the Databases and SQL Introduction course. Let's start this section about theoretical aspects about databases and answer the most basic question, which is, what does a database represent? Well, first of all, a database represents a way to store data. The reason we want to store data is to use it in the future. So as an example, we can think about the most basic way to store text data, which is a text file. In here I have an example about sales data that is stored in a text file called sales. And this is a decent way to store data as long as it's in small quantities. When we have a large amount of data, we won't be able to update it properly or delete some records. And most importantly, we won't be able to analyze it. So this takes us to the second point, which says that a database is an organized data storage mode. We can think about this organized data storage mode as a library where the books are grouped into categories. They can be arranged by the author, the language they're written in, and also they can be ordered alphabetically. In the same way, in a database we have tables which store different kind of data, and inside these tables we can order data by their IDs or any other attribute of the table. This is a database's conceptual schema. Here you can see that tables are represented, and each table has a name and some columns. For example, the company table has name and city as columns, and also there are some links between tables. In one of the next videos we will see that there are three kinds of links between tables, but in this example we only have one, which is one-to-many. So this link means that one company consists of many departments, in the same way that the department is located in many buildings. You see, one-to-many. And in the next sections we will see how to create such a conceptual schema, how to create the database with its tables, attributes, links, and so on. So a database stores and provides access to data from tables that are related to each other. You see that every table in the database has at least one link with another table, if not more than one, like the table department, for example. The integrity restrictions. The integrity restrictions are rules applied so that the data is correct and coherent. What do I mean by that? I mean that on every column of the database we can apply a rule to be sure that the data stored in that specific column is correct. For example, we may have a table where we store data about our customers, and each customer has a phone number, and if we know that every phone number has 10 digits, then we can apply a rule that makes sure that every value we store in that specific column has 10 digits. I can give you an example how we can write that in code. Let's say we have a phone number column and assign to it a check restriction that makes sure that the length of the phone number column is always equal to 10. Okay, so next we're going to talk about two essential components of databases. The first one being the DBMS, which is the database management system. This DBMS is a software component. There is no database without a software component. And this DBMS helps us take data from outside and put it in the database, and then use the data for reports. So the DBMS puts data into databases from outside, like text files, other databases, ERP systems, and then processes it and then lets us use in applications in order to analyze the data, to build reports, or just see the data or update the data or delete it or whatever we want to do with the data within. And the second essential component is the SQL, meaning the structured query language. This is the programming language of databases. This programming language lets us communicate with the DBMS, and using it we can define, retrieve and update data from the database. In the next video we're going to talk about the stages of creating a database.